Hi, hello, welcome back to our channel Chemistry with RK. Firstly, I would like to thank each and everyone, those who are contributing your subscriptions, like, shares and comments. So, I feel very happy when I see, this type of support from all of you. So, thank you so much for that. And then within one day, almost it is reaching from 400 to 500. Thank you so much for your support and love. So, at the same time, I'm going to give, all the concepts in an easier way of understanding. And then I'll make sure that, I'll give you all sorts of tricks and techniques to solve all the competitive exam questions as far as IIT and NEET is concerned. Thank you so much for that. And then please, I request, if you're new to the channel, so please do subscribe, and then don't forget to click on the bell icon for regular updates. So let's continue with our previous discussion, that is, we were discussing about the concentration terms in solutions. So we have discussed weight percentage, volume percentage, weight by volume percentage and molarity as well. So today let's start discussing about normality. So this is our fifth concentration term, which is going to be very important for our competitive exams. So generally we denote this normality with capital N, and then what exactly this normality? Like to discuss this normality, let me just go back to molarity. So we have discussed that molarity is nothing but that is the number of moles of solute present in 1 liter of solution. Similarly, the normality can be defined as it is the number of equivalents of solute present in 1 liter of solution. So in place of moles, we are going to consider the equivalents. So let me just give you the definition here. So we can write down, it is the number of equivalents of solute. So this number of equivalents of solute we are representing as E1, present in number of equivalents of solute present in 1 liter of solution. Yes. And now generally we represent volume of solution with V, and please make sure we are representing or we are taking this volume in liters. If you are going to take in milliliters, then we are going to take the help of 1000. So that we will see soon. Okay. So I hope it is clear. Normality can be defined as it is the number of equivalents of solute present in 1 liter of solution. And now if we try to write down the formula, that is number of normality is equals to, that is number of equivalents. Yes, number of equivalents. So we are going to write this as E1 because we are talking about the solute, and then present in volume of solution. So that is in we have to take it in liters. Okay. Yes. And now finally we can write down this normality is equals to E1 by V in liters. This can also be written as, okay. So if we want to express this volume in milliliters, we can write down this as E1 into 1000 by volume of the solution in milliliters. Yes, we can use any of this formula. And now if we just think about its units, okay. So if we just think about the units of normality, so units of normality are, they are going to be equivalent per liter. Hope it is clear. So the units for normality is going to be equivalents per liter. So which we generally write it as equivalent liter inverse. In short, we are going to write this as normal. So as how we have discussed molar for molarity, so here we are going to discuss normal for normality. So the units for normality is normal, which we generally see in our books indicating with capital N. Suppose let's say if we see capital N to beside any number, suppose, so it means that it is the value of normality. And then next here in place of this equivalence, we can write down, that is we can write down equivalence is equals to weight by gram equivalent weight. So if we substitute this particular value here in this formula, so we are going to get normality is equals to weight by gram equivalent weight into 1000 by volume of solution in milliliters. And now again we know that here we can write down gram equivalent weight can also be written as gram molecular weight divided by n factor. This is going to be very important. This n factor decides our answer. If suppose if we are going to miss taking this n factor, then we are going to get the value obviously wrong answer. And then here it is very important to understand what exactly this n factor is, that I am going to discuss very soon. Okay, and now if we substitute this value here, then what we are going to get? So that is normality is equals to weight by gram molecular weight divided by n factor into 1000 by volume in ml. Yes, and now this n factor will go into the numerator, so we can write down that it as weight by gram molecular weight into 1000 by volume of solution in milliliter into we have some factor called as n factor. And if you observe carefully, what is this term? We can write it as this particular term, weight by gram molecular weight into 1000 by volume of solution in milliliters. This particular term we can write it as, if I am not wrong, yes, your guess is very correct, that is molarity into n factor. So obviously if we are going to miss the normality, then we are going to express that value in molarity, so which is not correct. Okay, so when it comes to normality, we need to consider the n factor. So this is very important. So final equation, so this is going to be very interesting. So most of the questions we are going to solve by taking the help of this particular formula. So how to convert when we have molarity into normality? By multiplying with its n factor. So what is n factor, sir? Yeah, let's move on to n factor. So what exactly n factor? Actually n factor is defined differently for different compounds. So for acids we define n factor as basicity, for bases we define n factor as acidity, for salts we define n factor as total charge. So what exactly these terms? Let us see. So if you talk about for acids, the n factor is generally termed as basicity, and now the basicity is called as the number of H plus ions produced in the dissociation of one molecule of an acid. So what does it mean, sir? So if you take one particular molecule of an acid, so how many such H plus ions are produced in the dissociation? That number defines the n factor. Hope you understood. So I am just repeating the statement. So the number of H plus ions produced in the dissociation of one molecule of an acid is called as n factor for acids, which is basicity. And now let us just observe the examples here. So if you see, all these are the acids and their dissociations and their n factors. If you see HCl, in the dissociation it gives generally one H plus ion, so the n factor is 1. In HBr, it gives one H plus ion in the dissociation, so n factor is 1. And then HI, HNO3, HNO2, perchloric acid, chloric acid. So in all these compounds, if you can see, one hydrogen ion is being produced. So for all of them, the n factor is going to be 1. Hope it is clear. So let me give some more examples. You please try to take the screenshot. Okay, so here I have given few more examples. So just let us understand their dissociation, and then I left this particular n factor blank for you guys. So you please try to have a guess about their n factors. Okay, so that is chlorous acid. Okay, so this is chlorous acid. If you see, how many H plus ions are produced? 1. So I hope you know what is the n factor. It is going to be 1. And this is hypochlorous acid, and then again we have only one particular H plus ion, so its n factor is going to be 1. And then when we move to, that is formic acid, so here even though we have two hydrogens, but only one H plus ion is being produced. So what is the general n factor? So it is 1. And then why it is like that, sir? So since we have two hydrogens, only one H plus ion is being produced. Why that particular case is like that? Okay, it's not only about that case. So wherever we have this type of cases, actually if you try to draw the diagram of formic acid is going to be HCOOH. Yeah, this is the structure of formic acid. And now if you can see here, the hydrogen which is attached to oxygen can undergo dissociation easily compared to the hydrogen which is not attached to the oxygen. Okay, so why is like that, sir? So if you observe, the electronegativity of oxygen is very high. So oxygen would tend to pull the hydrogen's electron. So but whereas if you see, the carbon and hydrogen's electronegativity difference is very small, very less. So this particular bond is comparably strong compared to OH bond. So that's why not only in this case, in all the cases where we have the hydrogens attached to oxygens can easily undergo dissociation. So that we have to consider the number of H plus ions which are the number of hydrogens which are attached to oxygen can able to undergo dissociation easily, and those particular H plus ions are only we need to consider in the calculation of N factor. Hope it is clear. So that's why the N factor for formic acid is going to be 1. Similarly, if you see, the next one is acetic acid. Here you can see 4 hydrogens, but how many H plus ions are being produced? Only 1. Why? Because the same type of case here also. If you can see carefully, the hydrogens, 3 hydrogens will be attached to carbon, and only the 1 hydrogen will be attached to the oxygen. So that's why this particular hydrogen can only undergo dissociation easily. For that reason, the N factor is going to be 1. Hope it is clear. Please drop out your doubts in the comment section. I'll be replying to all your comments. Okay. Next, if we move to H2SO3 sulfurous acid, so it is going to give us 2 H plus ions, and then since because of we are getting 2 H plus ions, the N factor is going to be 2. Hope it is clear. Okay. And then next, let me just draw the structure of this so that you will understand. The group number of sulfur is 60A. So the maximum number of bonds it can form are total 6. Okay. So yes, actually this is what. And now H2SO3. So that's it. If you can observe H2SO3, so you are going to get, we are going to have H2SO3. Yeah. So this is the structure of sulfurous acid. So that's why both the hydrogens are attached to oxygen, so they both can undergo dissociation. Similarly, if we move to sulfuric acid, so we have got 2 H plus ions. Again, we are going to get a N factor of 2. And now what is the difference, sir? Here also the structure for sulfuric acid is this. H2SO4, and now for that reason 2 hydrogens are attached to oxygen, so that will those hydrogens will undergo dissociation. And the next oxalic acid, so again it is going to produce 2 H plus ions, so the N factor is going to be 2. Hope it is clear. Let me come up with some more examples on these acids only. You please try to take the screenshot. Yeah. Here are the 3 examples, that is H3PO4 phosphoric acid, H3PO3 phosphorus acid, H3PO2 hypophosphorus acid. And let us now just think about the dissociations and N factors for these 3 compounds. If you look at this H3PO4, we are going to get 3 H plus ions, and then PO4 minus 3, that is phosphate ion. Since we have got 3 H plus ions, the N factor is going to be 3. Yes, why, or like if I ask you why the 3 hydrogens have undergone that dissociation process, because we can get a thought that okay, so there could be 3 hydrogens directly attached to oxygens. Okay, yes. And now if you try to draw the structure, so phosphorus group number is 50A, the maximum number of bonds we can expect are 5. And now this is the proper structure. So if you can observe here, so H3PO4 structure is this. Yes. And now if you can see 3 hydrogens, all the 3 hydrogens attached to the oxygens, yes, all of them can able to undergo dissociation. Now when it comes to H3PO3, so out of these 3 hydrogens, only 2 hydrogens are going to undergo the dissociation, while the 1 hydrogen will remain with phosphorus. And now what is the N factor? 2. And now why is this particular compound has N factor 2? That is obviously, so it is going to give us, one of the hydrogen will be directly attached to the oxygen. So for that reason, this is not going to undergo dissociation, while only these 2 will undergo dissociation. Clear? And then next, H3PO2 hypophosphorus, out of those 3, hydrogens, only 2 hydrogens are going to undergo dissociation. It is going to give us H2PO2 minus. So the N factor is going to be only 1, which means that in the structure of hypophosphorus acid, only 1 hydrogen is directly attached to oxygen. Hence, that can only able to undergo dissociation. Hope it is clear. So these are the few examples which we can able to discuss in the case of acids N factor. Hope it is clear. You please try to take the screenshot, and then next we will move to the N factor for bases. Okay. Next, let's move to the N factor for bases. So generally for bases, the N factor we take it as acidity, and now it is quite opposite to basicity. So that is the number of OH minus ions produced in the dissociation of one molecule of a base is nothing but acidity. And now, so if you can see here, I have given few examples. So that is lithium hydroxide, all the first year group bases, and then I gave 2 second year group bases also. So that is lithium hydroxide can give 1 OH minus ion. So its N factor, which is acidity, is going to be 1. And then for sodium, potassium, rubidium, cesium, since all of them are first year group elements, so their what do you say, that generally forms monoacidic bases. Okay, so since their acidity is 1, we can call them as monoacidic bases. Okay, and then next that is magnesium hydroxide and calcium hydroxide, they belong to second year group elements, and then their particular base acidity is going to be 2 because they are going to produce 2 OH minus ions in their dissociation. Okay, so hope it is clear. So I'll give few more examples on this N factor for bases. You please try to take the screenshot. Yeah, so here we have few more examples for bases and their acidity. So that is, since these are strontium and barium are second year group metals, so they are going to produce 2 OH minus ions in their dissociation, hence their N factor is going to be 2. And then whereas aluminium, that is AlOH taken thrice, so it is producing 3 OH minus ions, so N factor is 3. And then ferric hydroxide also, it is going to produce 3. And then zinc hydroxide is also going to give us 2 OH minus ions. If you go for ferrous hydroxide, so it is going to give us 2 OH minus ions, so its N factor is going to be 2. So this is about the bases and their acidity, and then I'll try to discuss about the N factor for salts also. So meanwhile you try to take the screenshot. So let's move on to N factor for salts. And now generally N factor for salts we take it as total charge. So what is how to define this total charge? So charge multiplied by the stoichiometric coefficient of either cation or anion, we take it as the total charge for salts. So now if that is the case, if you come back to this example, so I have given a few examples. I'll give some more for your practice. And now if you take NaCl, okay, NaCl, that is Na plus and Cl minus in the dissociation. So if you can see, charge that is +1 and then stoichiometric coefficient is also 1. So we can take either cation or anion, that's up to us. Okay, so we should not take the sign, so we have to consider the number. So that is 1 into 1, so it is going to be 1 is the N factor for NaCl. And now K2SO4, potassium sulfate. So if you can see the dissociation of this, it is going to give us a 2K plus ions and then sulfate ion. If you can see the total charge, that is the charge multiplied by its stoichiometric coefficient, that is 1 into 2, so it is going to give us a 2. So I hope you understood. Next, if we move to aluminum chloride, Al plus 3 and then 3Cl minus. Even if we can directly take the cation or we can even take the anion. So if you see at the cation also, we are going to get the N factor is 3, and even if the anion also, that is -1, actually 1 into 3, so it is going to give us 3. And then aluminum sulfate, that is Al2SO4 taken thrice, if you can see, so it is upon the dissociation we are going to get 2 aluminium ions and then 3 sulfate ions. So what is the N factor for this particular salt? Please have a guess. So if you can see the total charge for this one, that is charge multiplied by its stoichiometric coefficient, it is going to be 6. Hope it is clear. And now please have a look about this zirconium phosphate. So try to understand. So if you can see the dissociation, we are going to get 3 Zr plus 4 and then 4 PO4 minus 3. So what is the N factor for this zirconium phosphate? So have a guess. I'm going to give you the answer also, so that n factor is going to be 12 because 4 into 3. Hope it is clear. So this is about the n factor for, what do you say, acids, bases and salts, and the concept of this n factor we are going to use in the case of calculating the normality. Hope it is clear. Please have a screenshot of this. Yes, let's continue. So we have seen this formula, that is normality is equals to molarity into n factor. So we have seen what is n factor just now, and now let's continue to derive some more formulas for the same normality. So whatever formulas we have derived for molarity, so all of them can be just substituted here, multiplied with n factor, we can able to calculate the normality. So all these formulas we are again going to use the same in the ionic equilibrium as well, in the calculation of pH and pOH at strong acids and strong bases. Okay, so you please try to understand that. And now we can write down, in place of molarity we can write down number of moles by volume, and then number of moles divided by volume can be written as weight by gram molecular weight into 1000 by volume in volume of solution in milliliters. And then the same thing we can able to arrange. So please, if you want a clear derivation and all for all these things, you please try to watch the previous video on molarity, so that you will be feeling very easy with this normality. So that is weight by volume percentage into 10 by gram molecular weight into n factor. Now when we convert this weight by volume into weight by weight, we need to take a density factor into the picture. Okay, so because we know that density is equals to mass by volume, but if you can see, we can write down volume is equals to mass by density. And now in place of this volume, if you can write down mass by density or weight by density, so the density will be going into the numerator. Hope it is clear. And next we can write down also, that is number of molecules by Avogadro number into 1000 by volume of solution into in milliliters into n factor. In terms of atoms, we need to consider atomicity. So this is the formula. And now when it comes to volume strength of H2O2, we need to take the n factor. Generally hydrogen peroxide H2O2 has a open book structure, and then we can see this type of structure actually. So where those two hydrogens will be attached to two oxygens, so it is going to give us 2 H plus ions with a peroxide ion. So since the n factor, what is the n factor for H2O2 then? So it is going to be 2. So if we substitute n factor is 2, then the formula will come out as normality is equals to volume strength of H2O2 by 5.6. Hope it is clear. So these are all the formula based, and then please you try to take the screenshot. We will move to the dilution principle in terms of normality. Okay, next let us move to some important information here regarding that normality. So this particular information I have given in the case of molarity as well. So if you can see here, the C normal is 0.1 normal, centi is 0.01, that is 10 power minus 2, milli is 10 power minus 3, semi is 1 by 2 actually, that is 0.5 normal, deca is 10 normal. So in case if you see any of these terms in the questions while solving the IIT or maybe NEET question, so if you see any of these terms, then we can able to say take these values. Okay, and next if we move to the relation between normality and temperature, very important here. Okay, so actually normality is inversely proportional to temperature, we say. Why is that, sir? Actually here temperature is related to volume through this ideal gas equation. It is directly, they both are directly proportional. So volume is directly proportional to temperature, so that is called as Charles law. Okay, so from this particular relation we can move back to this normality, that is normality and volume are inversely proportional. So since volume is directly proportional, normality inversely proportional to volume, so we can write down that normality is inversely proportional to temperature. What does it mean? As the temperature increases, volume expands. Volume expands, obviously the normality is going to decrease. Okay, so next if we move to the dilution law. So this case also we have seen in the case of molarity. So there we have taken two different conditions, two different cases, where in the first case the normality is taken N1, V1, but E, the equivalents are E. But if you, actually this is called as before dilution. Okay, so this particular case, let us take this is actually before dilution. So before dilution, the conditions are like this, okay, N1, V1 and E we have assumed. And now after dilution, which particular term are going to change and then which remains same? Okay, so after dilution, the normality is N2 and then volume changes to V2, but the equivalence will not change. So this is the important point which we need to understand here. Okay, upon dilution, there in the molarity, number of moles remains same. Here in the normality, equivalence will remain same. So if we apply the normality definition for this condition, that is N1 is equals to E by V1, N2 is equals to E by V2. So we can write down E is equals to N1 V1, E is equals to N2 V2. Since both the equations represents the same equivalence, so we can able to write down N1 V1 is equals to N2 V2. So this is called as dilution law. Hope it is clear to everyone, and then we will try to solve few questions. I'll try to give previous year questions in the next video actually. So let us just finish this normality, the theory part and all the applications of normality in this video. So you please try to take the screenshot. We'll continue. Yeah, let's move on to the concept of neutralization. So we know that neutralization is generally acid and base reacts to give salt and water. Okay, so generally it is an acid base reaction which are also called as neutralization reactions. So let us just consider for acid, I am considering the normality is Na, volume is Va and then equivalence is Ea. And then for base, Nb for normality and then Vb is the volume of the base, Eb is the equivalence of the base. And now if we apply the formula of normality to this acid, that is Na is equals to Ea by Va, and then for base, Nb is equals to Eb by Vb. And now we can write down the cross multiplying Ea is equals to NaVa, Eb is equals to NbVb. And now after all these things are bifurcated, and then next we will be getting three cases here. If suppose if the equivalence of the given acid is greater than the equivalence of given base, then we are going to see. So if the equivalence of acid is greater than equivalence of base, so how do we find out equivalence, sir? Yes, they will be giving normality and they will be giving volume in the question. Okay, and now by taking the help of those values, we can find out Ea and then we can find out Eb. And now if we observe Ea is greater than Eb, that is acid equivalence are greater than base equivalence, then we can say since the equivalence of acid is greater, we are going to get acidic solution. We know that for acidic solution generally pH ranges from 0.1 to 6.99. Okay, that is less than 7. And now in that case, the normality of the resultant mixture, they will ask us to find out the normality of the resultant mixture. So in such case, we can use this formula, that is normality of the resultant mixture is equals to equivalence of acid minus equivalence of base by total volume of the acid and base. And now we can write down Ea as NaVa and then Eb as NbVb. NaVa minus NbVb by Va plus Vb. So this is the formula we need to use only when the equivalence of acid is greater than equivalence of base. And then next moving to the second case where we get equivalence of base is greater than equivalence of acid, then obviously since the base equivalence are greater, we are going to get the basic solution whose pH is going to be from 7.01 to 14. So which is obviously greater than 7. Okay, and now yeah, if you observe carefully, okay, just a minute, sorry, this particular order need to be reversed, okay. Yeah, so this must be less than 7, this must be greater than 7, okay, right. And now let's continue. So if the equivalence of base is greater than equivalence of acid, then we are going to get normality of the resultant mixture is going to get by Eb minus Ea by Va plus Vb. Hope you understood. What is the difference between these first and second condition? Here acid equivalents are greater, so we have written Ea minus Eb by Va plus Vb. Here base equivalents are greater, so Eb minus Ea by Va plus Vb, which we can write it as NbVb minus NaVa by Va plus Vb. It is clear, okay, there is nothing to worry about it, okay. And then next, the last one, when if we get equivalence of acid and equivalence of base are equal, then we are going to get a neutral solution whose pH is going to be equal to 7. And then next, for such type of acid and base equivalence are same, then we need to apply, that is Ea plus Eb by Va plus Vb, which is nothing but equivalence of acid plus equivalence of base by total volume of acid and base, which can be written as NaVa plus NbVb by Va plus Vb. So this is all about the normality. So I have taken all the possible cases. So please I request you to follow the classes continuously without missing any of my classes. So please, you try to make all my lecture into your own notes, so that everything, you can maintain everything in one place, so that it will help you for the last minute of your IIT or maybe NEET preparation. Okay, so with this I'm going to end up normality. So hope it is clear, hope you understand each and everything. So thank you so much for your patience, and then please, if you are new to the channel, please I request you to subscribe, and then please spread my channel to your friends and relatives, those who are even the students, those who are preparing for the IIT and NEET exams. Okay, so thank you so much. Hope all this information will help you a lot. So soon I am going to come up with a new video on problem session on normality, which is going to be very, very, very interesting. So if in order to understand the upcoming problem session on this normality, everyone need to watch this particular video and make out all the formulas. Thank you so much. See you soon.